Hi, this is Jacob Nash with JNGL. Today we are looking at Unit 3, Lesson 4, and this is about indirect reasoning. So it's like one of those kind of things that seems like it's not even about geometry, and it's kind of short this time. And this is standard 3.6. I'm using slides today. This is the weather that's where I am right now, so beware noises. No, I know that looks like that's hardly any rain, but that's probably not even that accurate because it is pouring out there. And I just hope that didn't matter, that it was like kind of noisy. So, anyways, yeah. Definition. Well, it's talking about the definition of indirect reasoning. And this is a type of reasoning where all possibilities are considered true, even if you don't think they are. And then all but one are proved false. You then know that the remaining option must be true. So this is different than direct reasoning, where you're just like, oh, I can tell because of this. Well, you first have to consider them all true and then be able to tell at the end that it's true. And there's different steps you go through doing that, but here's an example to start out with. Well, you already know how to use it without me even telling you. You just don't know the specific steps and criteria you might need to know to answer the question. But here's an example. We have this triangle here. It is not equilateral, and you can already tell because this is 64 degrees. And if it were equilateral, then it would be 60 degrees, because whenever it is, it means all the angles are 60 degrees because they add up to equal 180, and they're all the same. So it's not that. It's just a basic triangle. We don't really know if it's obtuse, acute. Well, actually, we know it's acute. Anyways, angles 2 and 3, 2 plus 3, what could it equal? Well, direct reasoning would be, okay, we go and solve. 64 plus, no, that's not good. Because, you know what? That's not the right way you're supposed to do it for this. You have to eliminate answers. This might be what you do if you don't study before a test or something. You might do this because you're like, oh, okay, I know it's not that. Then I just have to guess with the two. Well, that's what this is basically. So, see what you can rule out. All right, A, 180. Is that possible? No, because we know that all angles add up to equal 180. If that was 0, that would be, these could be 180, but then it wouldn't even be a triangle. It would just be a line, a straight angle. So it's definitely not that. 128. Could that be possible? Well, you might think that it could, but first let's just start out by dividing that by 2. 128 divided by 2 is 64. If 2 plus 3 equals 64, or if it equals 128, then that means that they're both 64. If all angles are 64, that's more than 180. So it couldn't be that, because that would make all the angles add up to be greater than 180. 62. Well, is that possible? Let's again divide that by 2. 62 divided by 2 is 31. Well, 31, both angles would be, if 62 is a thing, a possibility could be that both are 31. Well, anyways, to start out with, 62, whatever of these numbers, if you add it to 64, it should equal 180 in the first place. 4 plus 62 is not 180, so that's not true. And we know that the only answer left can be true. So we didn't do what I just said. We didn't say, oh, which one of these adds up to equal 180. We get rid of the ones that are false, and then we find out what's right. We didn't have to do any math at all, other than trying to divide it in the calculator to see what could be possible. But there are specific steps that you need to know. So here's what they are. First, state what you know is false. That kind of sounds stupid, but when you have a statement, state what you know is false. Now it changes up things if the statement that you're starting out with, that, like, you'll be asked to prove that it's true. If you're asked that, then you follow these steps. But if you're not told that it's true and you know that it's false, like it's saying 1 plus 1 is 3, don't state that you know it's false, because in the first place it's false. You do a counterexample, which, if for an equation, that wouldn't be possible. But that wasn't a very good example. But if you get what I mean, what statement you'll start out with is true if you're going to follow these steps. So state that it's false, and you contradict the statement that's given. Then you show why it's false. Number 2 requires a lot of wording, and you need to use a if-then statement. Well, you don't really have to, but it ensures that your answer will be specific enough. If you can state an if-then about why it's false, then you know what you're talking about. But if you just say something kind of simple and short, then your teacher might not know that you know that's false. You have to prove it. Like if you were in a what do you call it? Like argument session. And then the final thing is you state the true statement. That's all you have to do. So state the false statement, state why it's false, and then state the true thing. So if you were doing that for this one, we could, if we're saying angle 2 and 3 equals 16, then you would say it's not 16. Okay? Why? It's not 116. Then say why the statement that it's not 116 is false. That's kind of a double negative there, but you could say because 116 plus 64 equals 180, and then you state the true statement. Angle 2 plus angle 3 equals 16. Okay, now try this. Use indirect reasoning. A clock cannot read 7 a.m. 8 times a week. Alright, pause the video, just do this. Okay, first statement is to state what you know is false. We know a clock can read 7, 8 times a week is false. We know that's false because we know that if we're trying to use indirect reasoning, the one that they give you is the true statement. So you just reverse what it says. Cannot, can. Then state why. Alright, first you can start off with a short sentence, and then you can do it if-then. There are 7 days in a week. Alright, that's a fact that proves it already. But then to further elaborate, we can use the if-then statement, which is if a clock reads 7 a.m., then it can only do so 7 times a week, because there's only 7 days in a week, so that would be impossible. It doesn't repeat 7 a.m. that many times. And then step 3 is just to restate the statement. A clock cannot read 7 a.m. 8 times a week. Wait a minute, is that okay? Well, you might notice that for number 3, or step 3, it's the exact same as what the question was in the first place, or really the statement that they were making you prove that it's true. That's fine. That's what usually will happen. It might be a little bit different, but usually it'll be about the same thing as what you get in the first place. Oh, no more arrows. Okay. Sorry that I didn't make a thanks for watching slide this time, but that is what I'm going to say. Thanks for watching, and you'll have the last video for this unit whenever I post it, unless it already is there. I don't know. Okay. Thanks for watching.